Elon Musk's SpaceX has grabbed the multi-million-dollar contract to launch the Nancy Grace Roman Space Telescope mission that will analyze the effect of dark energy, dark matter, and exoplanet exploration. The telescope will be initiated on board SpaceX's Falcon Heavy rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida in 2026. The contract has been pegged at almost $255 million, which contains the launch service and other mission-related costs. In a statement, the American Space Agency said, the telescope's mission is currently targeted to launch in October 2026, as specified in the contract, on the Falcon Heavy rocket from the Launch Complex 39A at NASA's Kennedy Space Center in Florida. But what is Nancy Grace's Roman Space Telescope? The Nancy Grace Roman Space Telescope is designed to find answers to questions surrounding dark matter and dark energy. Scientists believe that 68% of the total energy content of the cosmos is dark energy, and it is driving the expansions of the universe. NASA has said that cosmic accelerations could be affected by a new energy component, which would require some adjustments to Einstein's theory of gravity. Equipped with a mirror that is 2.4 meters in diameter and at the same size as the Hubble Space Telescope's primary mirror, the Roman Space Telescope will have a field of view that is 100 times bigger than the Hubble infrared instrument. The spacecraft will be equipped with two instruments, the Wide Field Instrument and the Coronagraph Instrument, that will assess light from a billion galaxies over the course of the mission's lifetime and complete a microlancing survey of the inner Milky Way to find over 2,600 exoplanets. The telescope will have an accurate lifetime of 5 years, with the possible mission's expansions of another 5. The development of the mission started way back in 2010 after its suggestions in the New Worlds or New Horizons report of the 2010 National Academy of Sciences Decadal Survey for Astronomy. The development started in 2013. Roman's wide field of view also will allow astronomers to put individual galaxies into context by seeing how their growth surges and following slowdowns, which vary depending on their locations within the cosmic web, the large-scale pattern of the universe. If you're liking this content so far, please consider subscribing and liking this video. Now let's continue. The science objectives of Roman aim to deal with cutting-edge questions in cosmology and exoplanet research, including answering basic topics about dark energy, complementary to the European Space Agency Euclid mission, and including is cosmic accelerations inflicted by a new energy component or by the breakdown of general relativity on cosmological scales. If the reasons is a new energy component, is its energy density steady in space and time, or has it evolved over the history of the universe? Roman will use three self-sufficient techniques to probe dark energy: baryon, acoustic oscillations, observations of distant supernovae, weak gravitational lensing, completing a census of exoplanets to support answering new questions about the ability for life in the universe. How common are solar systems like our own? What types of planets exist in the cold, outer regions of planetary systems? What determines the habitability of Earth-like worlds? This census makes use of a technique that can discover exoplanets down to a mass only a few times that of the Moon, gravitational microlensing. The census would also include a sample of free-floating planets with masses possibly down to the mass of Mars. Creating a guess, investigator mode, allowing survey investigations to answer various questions about our galaxies and the universe. Giving a coronagraph for exoplanet direct imaging that will provide the first direct images and ranges of planets around our closest neighbors, similar to our own giant planets. A SpaceX Falcon 9 rocket was also blasted off with NASA's Imaging X-ray Polarimetry Explorer satellite. It was first announced in 2017. The IXPE is the first satellite capable of measuring the polarizations of X-rays that come from cosmic sources, such as black holes and neutron stars. The Fridge-sized satellite has 3 telescopes that can track and assess the directions, arrival time, energy, and polarization of light. When data from all those telescopes is blended, NASA can form pictures that could give us more insight into how mysterious celestial objects work. For example, they are wishing it can provide us a more thorough look at the systems of a Crab Nebula, a supernova remnant with a neutron star that quickly spinning in its circle. By identifying black holes, the IXPE will benefit scientists, gain more insight, and broaden humanity's knowledge on the areas of space we still hardly know. It could give clues on why they spin and how they gobble up cosmic materials. However, it could also lead to new findings. Martin Weisskopf, the mission's principal investigator said during a briefing. IXPE will help us test and refine our modern theories of how the universe works. We may even find out more thrilling theories about these different objects than what we have hypothesized. SpaceX has also used a Falcon 9 rocket from an earlier missions for this launch. If all goes well, the rocket's first stage will land on the company's drone ship. Just read the instructions after shipping IXPE to space. With that being said, it's time to end our today's video. Press the like button and subscribe to our channel for more interesting stuff.